Hello and welcome to Cambridge. We're here for the In Situ Hybridisation and Spatial Biology Symposium, where researchers, vendors and technology companies in the space are looking to push the boundaries of single marker detection onto multiplexing and use our understanding of proteins, RNA, AI to better understand the tumour microenvironment. Let's go have a look inside. I now have the pleasure of being sat here with Pedro Espinosa, who's the Senior Field Applications Scientist here at Indica Labs. And I'd like to start by asking, why is this such an important area for Indica Labs to be in?
Well, our history with image analysis at its whole, it's really important for us. That's the reason the company was built back in the days. So we really know, like, from the really early beginnings, how the image looked like, how we can develop the tools to analyze it further, and more importantly, on this symposium, the ISH Symposium here in Cambridge, our history on analyzing ISH probes really go back in the days also with our first collaboration with ADC, way before they were Biotechnique Spatial and things like that. We were one of the, I don't dare to say the only one, but we were one of the commercial solutions that could really do ISH analysis, detect the dots on a per level basis.
Okay, great, thank you. And we've just listened to your really insightful talk on this subject. And something that really kind of shocked me was how many service requests you get when it comes to tissue. And a really important point that you made was controlling your upstream processes.
Yeah, definitely.
Yes.
That's a very, very important point. And I think we're getting all these calls on our side, even though they are not image analysis related, because our level of support is well, what can I say? I work for it. So it's really high, and we have lots of knowledge on it.
Yeah.
So it's really rewarding that they count on us on that aspect. But as I say, this is not related to image analysis. We need to control the upstream process of how things are done, how the tissue has been processed, how the tissue...
The example that you gave, we were looking at some really dodgy tissue there.
Yeah.
And the clear point is, if you put rubbish into the system, you're going to get rubbish out again. And
definitely,
you as the image analysis guys, there's nothing that you can do about that.
No, definitely. That's the point. And I think that some people in some labs are just giving it for granted, like slicing the tissue, processing the tissue. That's something like so routinary that people are not paying enough attention to it. And then when they come to analyze those images, those stainings, nothing makes sense because everything's mixed up.
Yeah.
So it's really, really important to do that. I will say as important as having a nice tool to do the image analysis. Reproducibility and batch analysis. I will say those are the two key parts.
Yeah. No, great highlight there. And what excites you most about this industry, this area?
I really love how it's evolving all the time. I remember back in the days when I started doing this, I was just an histology clinician behind the microtome, slicing all day. And the moment you are aware of the amount of information you can subtract from these images, it's just amazing.
Yeah.
It's not only like areas, it's on a cell-by-cell level, on a chromosome level even. The amount of information that can be subtracted, it's just amazing.
Yeah.
And then related to spatial biology, spatial analysis, before we just focus on classifying those cells, CD3 positive cells, CD8 positive cells, CD68. Right now, it's as important to understand the environment of that cell, where that cell is located and how it's interacted with the rest of them. That gives you a lot of information about, for example, treatments, prognosis, etc. I really love that and how it's evolving, of course.
Yeah, thanks so much, Pedro. And, kind of to extend that question, where do you think it can go from here as well?
That's an interesting question. It has evolved so much. Of course, I think that, again, controlling that upstream process, which is currently made in a very classical way. But we can do way more, much better on the image analysis side, with better resolution images, with more accurate signaling, labeling, staining, things like that. So I think that's the direction where it's going, but without losing the mind that everything, especially on the clinical or translational aspect, needs to be or will need to be related to human samples. So it needs to be feasible and understandable as well. So that we need to bridge that gap.
Thank you so much. Nice to have you on.
Thanks.
So I want you to notice that you see these flashes, hopefully. And what you can ask is, how long does a flash last? And that's the binding time. And what we see is that the binding time is on the order of 1 second. Okay? So, which is all fine, but now you need to compare it to your bursting measurements. And that's definitely different from 1 second, because bursts last on the order of 5 minutes.
Hello and welcome back. Now we've got a really good opportunity here to sit down with a team of people that have been instrumental to this meeting. I'm sat with Dr. Juliet Jones, Dr. Will Howard, and Professor Scott Fraser. Julia, I'd like to start with you. Why is this meeting so important for the field?
Well, I think there isn't, as somebody said to me yesterday, there isn't any meeting that's quite like this one. And I think that's really what we're trying to do. We're trying to bring like the newest in situ technologies to kind of everyone. So, from PhD students up to group leaders, and in a variety of different fields. And I think for me, it's really important that we kind of address the technology and bring it to people so that they can implement these technologies in their own labs.
It's great to see so many people from so many different facets here as well. It's not just the researchers you've got here, you've got the technology companies as well. And I think those conversations are really important to have between both groups.
Yeah, I think we've seen that there are like 81 different affiliations across the delegates that are here. So just shows like what a broad set of people we've got.
Fantastic. And as you say, a really unique meeting. Will, I was hoping to come to you then and ask you, where does spatial biology fit into the bigger picture here?
Well, I think I've been in pathology for quite an awful long time. And I think what I see now is that it is the most rapid change in pathology, I think, that we've had, with either the digital pathology space changing, but equally here where we're looking at not just spatial proteomics, but also the spatial transcriptomics side of things, independent, and then combining more and more together to try and grow this kind of scientific area and understand which one leans in which one.
Absolutely.
And where does a protein play a role, and where does the transcriptomics, which is developed faster, is able to kind of lean and deliver different results.
Now, are those technologies coming together into one mass data set that we can use for
that would be
diagnostics
lovely. I don't think we're there yet. I think there's still a lot of work to do to get those to combine together in an accurate way, particularly if you're going to go into a diagnostic setting. And obviously it's got to be accurate for patient benefit. So getting to that stage, we've got to have really good, robust techniques, and make sure that the field are applying those robust techniques, throughout everybody.
Thank you. And Scott, coming to you, have you got any key takeaways from this meeting?
Well, for me, what makes this meeting so exciting is that I think we are seeing modalities being fused together and spatial dimensions being fused together. Now, in today's talks, even time scales being fused. And so the ability to do multi-scale biology really at scale is what we're going to need to train the next level of AI. And that's what's really going to empower us all to go that next generation. I think we're seeing this exponential growth in the buy-on of these techniques and the use of their insights. I think that doing multi-scale biology at scale is really our goal.
Would anyone else like to add anything to that?
No, I just think it's been a brilliant conference to be part of. Julia organises it incredibly well, and I hope that we continue to kind of see the benefit of that, bringing people together, and continue on with it in 2 to 3 years' time.
Fantastic. Well, thank you all for that very brief interview. Really enjoyed it, and an insightful bit for our audience. Thank you.
Thanks.